Welcome to Ushendra's engineering tutorials. Once again, introduction to signals for beginners. Right. So here, what will be the resultant of this one? It may be you may be asked to sketch this one. It's a ramp signal. So what will be the resultant of this one? Right. Once again, sticking to my previous statement, this is a manipulated version of R of any beginner might think that it's a negative, so it might this will be commencing from t equal to 0, and what strikes in the mind of a beginner is that it may start from -1. No, it starts from +1. This is the proof. R of t minus 1, t1 minus 1 for convenience. R of t minus 1 is a manipulated version of R of t. My R of t starts commencing from t equal to 0, like this one, with a unity slope. So in that case, t minus t1 of -1 is a manipulated version of t, and t1 is equal to t plus 1. It starts from the original version. The actual R of t starts from t equal to 0. So the manipulated version of this, where it starts commencing from here, this one. When t equal to 0, my t1 will be equal to 0 plus 1, which is equal to plus 1. Here, this is the starting point for the manipulated version. So it starts commencing from here. It may be t equal to 0 over here. We have t equal to plus 1. So it starts commencing from here. Right? In the same way, this starts commencing from t equal to plus 3, and this starts commencing from t equal to plus 4, and this one we have a negative slope here. It's a negative slope, and this is a negative slope, this is a positive slope. Take care of that. And slope is unity, one increment in time, one increment in slope, right? And it's an addition of four different ramp signals, so it would be convenient, it would be easy for you to understand if you draw it on a even you demand for a graph sheet. Right? How to plot this one? R of t, it starts commencing from, it's a black one, keep watching. Is it writing? Yes. R of t, it starts commencing from t equal to 0, like this slope. This is the slope. 1 and 1, 2 and 2, it goes like this. 3 and 3, it goes on, and 4 and 4, and it goes on up to infinity. For this one, for the first one. Right? What about this? With a negative slope, even with that unity slope, this is a negative slope, starts commencing from t equal to plus 1. So t equal to plus 1 here, it's this one, and one slope. Don't get confused. Right here, this is 1, and this is 1. From here, so we don't match with 2 and 2. No, it is commencing from this one. So 1 and 1, like this one, and it goes on like this, and goes on like this. It goes on to infinity. Right? And what about this one? This one with a negative slope, it starts commencing from t equal to -3. Here, no, sorry, very sorry, I'm taking back that word. It's not t equal to -3, t equal to plus 3. So here, it's a plus 3 over here. What would be the signal? What would be this looking like? With the negative slope, we'll be having this 3 with this one, with this one, with this, and this. It goes on to infinity. Right? So this is what it happens. And what about this one? Even this with a positive slope. Here it's a positive slope. I remind you, now this is a positive slope. You may think it is continuing. Yeah, it's a positive slope. Starts commencing from t equal to plus 4. Yeah, so this would be the resultant here. This one, and this one, and this one. It goes on to infinity. And adding these two here, do we have prior to this one? Close this away. Do we have prior to this one? No. Like it's 0, it starts commencing from 0, and here, what is this? At t equal to, we have time period on this one, right? T equal to 0.5, it's same, so it's continuing. T equal to 0.5, it's same. Now at this point, even this point, it's 0, and this is amplitude is 1. This is 0. Add these two, this is 0, and this one, it goes on continuing, like it may be 1. Now focus on this point. Focus on t equal to 2. Focus on t equal to 2. Focus on t equal to 2. Here we have 2. At t equal to 2, we have the amplitude 2, and coming down we have -1. plus 2 and minus 1. Plus 2 minus 1, that will be 1. So at t equal to 2, the resultant signal is 1, plus 1. We have plus 2. At the same time, t equal to 2, we have plus 2 and minus 1. The resultant is 2 minus 1. It's a 1, positive 1. So this would be the signal here. This would be. And at t equal to 3, watch carefully. We have 3 plus 3. Signal amplitude is plus 3, and looking down we have minus 2. 3 minus 2, it's 1 again. At t equal to plus 3, we have 3 plus 3 minus 2, which is 1 again, so it continues, right? And at t equal to 4, here, what we have is this one. This is 4 plus 4, coming down it's a minus 3, right? It's a plus 4, it's a minus 1. Yeah, once again I repeat, it's a plus 4 here, it's a plus 4, it's a minus 1, and it's a minus 3. So plus 4 minus 4, that would be at t equal to 4, it has to come down to 0. Yeah, this is my, it should be bigger one, I'm sorry, it became a very small one, right? So this is my final resultant. So here, what would be the sketch of this one? R of minus t into u of t plus 2. A ramp signal is multiplied with a step function. So what is R of t? R of t with a positive time period and positive amplitude, it would look like this one, commencing from t equal to 0 with a unity slope. And R of minus t is the flipped version of this one. It's just flipped around the vertical axis. Here, R of minus t, positive amplitude with a negative time. This would be the resultant. Flipping this signal with respect to vertical axis. This would be my R of t minus 1. And what about u of t plus 2? U of t plus 2 starts commencing from t equal to minus 2. Right? I stick to my previous statements. This one, u of t plus 2, and it's a positive. Okay. So here, drawing these two, R of t, what we have is starts commencing t equal to 0, t tending to plus infinity, and t tending to minus infinity. This would be my resultant R of t minus R of t. This is for minus R of minus t, sorry, not minus R of t, but a positive amplitude with a negative time axis, right? And how this would look like here, continuing over here, we have t equal to 0, the sketch of u of t plus 2 unit. It should start commencing from what? It should start commencing from t equal to 0. U of t should start commencing from t equal to 0. We are adding 2, bro, this is for you. We are adding 2 units ahead. Like this may be t equal to minus 1. This may be t equal to minus 2. And this step signal would start commencing from here with a unit amplitude 1. This is the amplitude. Nothing is over here, indicating that it's a unit step function, advanced. This is known as advanced step function, right? And multiplying this to, it's tending to infinity. Okay, it's tending to infinity. It goes on. So multiplying these two, the resultant would be looking like this one. The resultant would look like this one. T equal to 0. Yeah, it's a 1 up to this point. Prior to this, we don't have anything. It's a 0 over here. So 0 multiplied with anything, that will be 0. Okay, so this may be up to here. It's a 0. And it's a unity, it's a 1. Anything multiplied with 1, that will be this one. This, whatever this signal multiplied with 1 results in this one. So my multiplying these two, even this one, 0 into 1, that would result into 0. Whatever this signal, this ramp is multiplied with unity, so this is reproduced as it is. This is the resultant. With we have 1 over here, right? This is my resultant when these two ramp function and step function are multiplied. We don't have this anymore. We have 1 over here, but this becomes 0, so we don't have all that. It's 0, so we don't have anything over there. This would be my final resultant sketch of that one. And how this one, this is another important and confusing corner for a beginner. Looking at this value, a beginner might think that there would be a shrink in the time period. No, it's reverse. Like let me explain. Stay with me. Now it's a manipulated version of r of t. My r of t, our r of t starts commencing from t equal to 0, like this one, right? T equal to 0, and now we have a negative time period, so definitely that signal, it would start from here and something else some manipulated, right? So it's a negative time, 0.25 times negative time, that will be in this quadrant, and that would be the resultant. We need to have and a shift over here, and advanced shift over here. So the given r of minus 0.25 t1 for convenience plus 1 is a manipulated version of r of t, right? In the sense the time 0.25 t1 plus 1 is a manipulated version of t, the original version t. What I have is t1 will be equal to t minus 1, right? And this negative 0.25 comes that side, it's a negative 4, and negative this one, that becomes plus 4. Yeah, this one, when I drag minus 0.25 to this side, this would be the resultant. It's a plus 4, right? My r of t starts commencing from t equal to 0. So where the manipulated version of r of t with these manipulations starts commencing from is a point. Like when the original r of t starts commencing from t equal to 0, our t1 would be, t1 is equal to minus 4 into 0 plus 4. So this, the resultant, our manipulated signal, this one would start commencing from plus 4. Bro, this is for you, t1, right? And the sketch would look like, and I stress, nothing is done with the amplitude. Nothing is done with the amplitude. So this is the sketch of that one. Let me draw with this one. The sketch would be actually r of t. Here this is the sketch, t equal to 0, and rt1 starts from t somewhere else here, t equal to plus 4. This one, the manipulated will start commencing from t equal to plus 4 with a negative time period like this one. It will be like this. Why? Because r of minus t is this, right? A shifted version. And remember, this is the amplitude. We have done nothing with the amplitude. Slope will be unity in this case, right? So this one, you may the beginner might think that there is a shrink. No, there is an expansion. If it's 0, like this is the one, right? So hope you understand these basic signal operations. If you find this useful, please subscribe to Ushendra's engineering tutorials. Stay tuned to Ushendra's engineering tutorials. Thank you so much for being with us.